Hi students, problem number 5. N tuning forks are arranged in order of increasing frequency and any two successive tuning forks give N beats per second when sounded together. If the last fork gives double the frequency of the first, show that the frequency of the first tuning fork is f equal to n minus 1 into small n. So this is a very important numerical for competitive exams, and here the language given here is to be understood. So read the problem thoroughly till you understand. So how many number of tuning forks are given? First of all, you tell me. It is capital N, is it not? So N, capital N is the total number of tuning forks. So we will group up the given information. Okay, we don't know the exact number, but capital N is given. Then when two successive tuning forks means the first and the second, or the third and the fourth, like that, nth and n plus 1th. Okay, when they produce a small n number of beats per second. So what is small n? This is the number of beats produced per second. That's the beat frequency. Okay, what hint they have given, children? If the last tuning fork gives double the frequency of the first. Okay, so let us take a small f is the frequency of the first tuning fork. So frequency of the first tuning fork is taken as what? F. So the frequency of the last tuning fork, nth tuning fork. So frequency of the nth tuning fork is equal to twice the frequency of the first tuning fork. We can take F1 or F also. I will take F itself. That is the first tuning fork. So these are all the given hints from which we can solve. Okay students, now the first tuning fork and the second tuning fork, they have a frequency difference equal to small n, because n number of beats are produced, is it not? So I will take f, the first frequency is f, then the next frequency must be what? F plus n. And the third frequency must be what? F plus n plus n, that is 2n. So like that, in this series, what will be the last frequency? I have to write, is it not? For that, I will rewrite this same in a different way so that you can understand easily. F also can be written as what? F plus 0 times n. Okay, 0 into n. The next one can be written as what? F plus 1 into n. 1 into n. And the third one, the third frequency is what? F plus 2 into n. So the first term here, F is F plus 0 times n. Second term is 1 into n. Third term is what here? 2 into n. So fourth term, it is 3 into n. Fifth term, 4 into n. What will be the nth term? N minus 1. Is it not? N minus 1. Capital N minus 1 into small n. So here the last one must be equal to what? F plus n minus 1 into n. So the last term is F plus total number of tuning fork minus 1 into number of beats. So this concept, are you all understanding first? So small f also can be written as f plus 0 times n. So next to f plus n can be written as what? F plus 1 into n. Third term is f plus 2n. Fourth term is f plus 3n. So capital nth term is what? F plus capital N minus 1 into number of beats is small n. Okay, now you see here, f is the frequency of the first tuning fork, and f plus n minus 1 into small n is the frequency of the last tuning fork. Is it not? If the last fork gives double the frequency of the first, means what you understand? the frequency of the last tuning fork is 2 times the frequency of the first tuning fork, is it not? So given that the last tuning fork f plus capital N minus 1 into N is equal to 2 times f. Okay, this is the information they are given. So this f is going to the other side. It will become 2f minus f. So 2f minus f is equal to what? N minus 1 into N, or f, 2f minus f is what? F itself. So f is equal to N minus 1 into N. So this is what we are supposed to prove here. So show that the frequency of the first tuning fork is f equal to capital N minus 1 into N. Understand that? So we have proved that the frequency of the first tuning fork f is equal to capital N minus 1 into N. I hope you must have understood well. Fine.